my name is Mariela Sanchez, and this is my math teacher Desmos account. For the following final, I decided to choose option A. So for option A, it told us to choose 3 activities involving statistics and 3 activities involving geometry. So first of all, and before going into this, you have to find out what is statistics. So statistics is a mathematics that focuses on gathering, analyzing, and interpreting quantitative data. The purpose of statistics is to use numbers to understand people and events in the society. Often scientists use statistics to find policy analysis. They use numbers or data to help devise solutions for societal issues. So next we have geometry. So when thinking of geometry, whenever you ask an elementary student, they say shapes. So this is true. Geometry is the branches mathematics concerned with shapes of an individual object, spatial relationships among various objects, and the properties of surrounding space. It is one of the oldest branches of mathematics in response to practical problems of those found in surveying. So first, I'm going to go into 3 activities involved that I looked on the Desmos account and I thought would be helpful for elementary students. So these 3 activities would help students with angle relationships. They would explore terms such as scalene, obtuse, right, isosceles, and equilateral, and they will look into area and volume of important characteristics of 2D and 3D shapes. So the first activity I found that was really cool was called Laser Challenge. In this activity, students use angles to adjust lasers and mirrors as they seek and hit triangles in series of challenges. For younger students, so this would be an excellent activity to think about angle measure. And for older students, this offers a chance to critically think about properties of angles, lines, and reflections. So this activity might take longer than 1 class period, as it shows over here 60+ minutes. So you might have to do this activity for 2 class periods. While doing this activity, I personally found it really cool because you would adjust your laser and aim it at a mirror, and by doing so you would try targeting certain areas, and I thought kids would think this was fun and it would be like a kind of game. So the next activity that I was looking at is polygraph triangles. It's not as long as the other activity. For this one, only takes 30 to 45 minutes. And this one's all about triangles. And what's just really cool about these activities is that it introduces kids to triangles. So students would ask questions, and when you're introducing this activity, you would introduce terms such as scalene, acute, right, isosceles, and equilateral. So in this activity, you graph these shapes, and even though they may not, when students don't know what these shapes are, that's when you step in and start introducing them, the shapes on the board. So the next activity is cylinders. So in this activity, students use strategies and volume of a cylinder. They build based on what they may have seen in earlier grades. They multiply the area and the base and shape and the height of the prism. So this activity, it's not as fun as the other activities, but still it's interesting in which it introduces formulas, and these students have to apply the formulas to the numbers given, and in which they find the volume and surface area of cylinders. So these are my 3 activities about statistics. So in statistics, you would find graphs of position to help introduce your ideas of function to have a single output for each individual or input, functions and non-functions, domain and range. So here's my first one activity I did. It was turtle crossing. So in this students make connections between several turtle crossing scenarios and the graphs that represent these scenarios. So this one was pretty cool, in which the turtle had to cross certain areas and obstacles. And in order to do this, students had to find graphs to represent this scenario. This was a pretty cool activity in which it gave you a goal. The next activity was Guess My Rule. So students are introduced to the concept of functions by using input and output pairs. In the table, they explore different rules, some which are functions and some which are non-functions. Some rules are numeric, while others involve letters and words. This is pretty cool because when you're doing Guess My Rule, it gives you a rule that's either a function or not a function. And by doing Guess My Rule, students had to find the rule, and they had to determine, is it a function or is it not a function? So the next activity which I had was domain and range introduction. So in this activity, students practice finding the domain and range of piecewise functions. They begin with an informal exploration of domain and range using a graph, and they build representing domain and range of piecewise function using inequalities. So this was pretty cool because it had students once again explore domain and range. It has them using graph. Let me go back. It has them using graph and building to represent the range of precise functions using inequalities. So while they're doing this, the Desmos activity graphs for them, so it shows them how their graphs would be introduced. So now I'm going to go into the Desmos activities that I did. So the first Desmos activities what I did was welcome to adding numbers. It was my statistics activity. So in this activity, students practice adding whole numbers in the concept of a card game. The goal of the game is to use 2 groups of cards, each with the same sum. Whoever has the greatest number wins. So basically, the concept is you have a red square and a blue square, and you want to make these squares equal the sum, but you want to have the greatest number of cards in there. So like over here, I did 3 plus 2, which is 5, and 4 plus 1, which is 5. I used all my cards, and they both equal 5. And over here, it was a little bit more challenging because I had 5 cards. After doing several practice rounds, I found that the only concept that you could get in the red card solution is 5 plus 2, which is 7, and 3 plus 4, which is 7. So I had 1 left over, but my score was ultimately 4, I should say. So in this one, I had 3, 4, 5, 6 cards. So in the first section, I had 7 plus 6, which was 5, 10, 11, 12, 13. And then the second box, I was able to add 3 cards, which is 8, 9, 10, 11, 12, 13. So in this one, I got a score greater than the previous one, which is 13. Or 5, I should say. With 1 remainder left over. So over here, it called me to reflect. So what strategies have been helpful to you? Many cards as possible. So I mentally added the cards and attempted to make as many combinations as possible. And in this card scenario, it's 7 again. So I did 9 plus 1 plus 3, which is 13. 7 plus 2, which is 9, plus 4, which is 13. So in this card combination, I got a total of 6 card combinations in total. So in this one, it was pretty interesting, a little bit difficult, because I had a total of 8 cards, but I managed to do it. I did 9 plus 2, which was 11, plus 8, which is 19. Then I did 6 plus 4, which is 10, plus 3, which, let me go back, sorry, I skipped the slide. 6 plus 4, which is 10, plus 3, which is 13, plus 5, which is 15, plus 1, which is 16. So in this one, I had to settle a dispute. It says Arito claims that it is possible to use 7 cards here. Brianna says the most you can use is 6. Who is correct? And in this one, you could actually use all 7 cards, because what they weren't considering was that the last card that's over here is 0. So you could add that card into any of these ones, and it won't have an effect on the sum. Okay, so now I'm going to go into my math activity, in which I involved geometry. And this one I did cylinders. I chose cylinders because this activity wasn't really fun, but still it's an important concept that elementary students have to learn. So how many unit squares will it take to fill up the rectangle? So I did 3 times 4, which is 12, and that little square is 1 by 1, so it would take 12 units to fill up the rectangle. So over here we have a rectangular prism, and it asks how to find the surface area of it. So in order to find the surface area, you need 2 times L times W plus 2 times L times H plus 2 times W times H. So I applied that formula to over here, so it would be 2 times 12, which is 2 times, sorry, it keeps on skipping. Two times 12, which I got was 2 times 3 times 4, which is 12, and then 2 times 15, which is 3 times 5, plus 8, which is plus 8. So 2 times 12, which is 24, plus 2 times 5, which is 30. And then you have your 8 over here. So and when you add all that together, you get 60. So your total over here is 60. So the next one is asking you to look at an equation and explain, over here it's asking to explain what the 12 and what the 5 represent figures for Deandra's first equation. So the 12 over here represents the base, 3 times 4, and then the 5 represents the height. So it's asking over here, use Deandra's strategy to write expression for the value. So in order to find Deandra's strategy, all you would have to do is 5 times 8, which is 5 times 8, which is 40, times 6, which is 240. So here's Deandra's described the strategy to finding the volume of a prism. First, you find the area of the base, then you multiply the area by the height of the object. So it's asking you to find which of Deandra's strategies would work on these shapes. So it would work on A, it would work on C, it would work on D, and now looking at it, I didn't choose it, but it will work on E. And the great part about this is it asks students how you decided, so give students a chance to interact. So it's asking what information you would need to calculate the volume of a cylinder. So in order to find the volume of a cylinder, all you need is to find the height and the radius of the circle. Then after that, you could use the height and the radius of the first circle, apply the numbers, and you could find the volume of a cylinder. So here's the cylinder from the previous screen, and it was asking you over here to find the height of it. So the volume of a cylinder is over here. It's pi times r times square times the height. So what I did over here, I did the volume would be 3 squared, which would be 9, times 10, which would be 90. So the volume of the cylinder over here is 90. So here's another one. So it's having me correct a claim. So Casey claims that the volume of the cylinder is 30 inches. What might that Casey be thinking? So she multiplied the radius times the height. So it's 3 times 10, which is 30, which we know this isn't the volume of the cylinder, as we discussed earlier. So over here it's asking me to create 2 different cylinders with the same volume. What is the volume of one cylinder? So the tall, skinny cylinder, as you can see, you don't have to really apply the formula. It would just be 12. For the tiny cylinder, it would be 2 times 2, or 2 to the second, which is 4, times 3, which is 12. So that would be 12, would be the volume of that cylinder. So which cylinder has a greater volume? This is a great activity for students because it would show just because something's taller doesn't actually mean it has the more volume. So the volume of the tall, skinny cylinder is 6, or the volume of the second cylinder would be 2 to the second, which is 4, times 2, which is 8. So 8 is greater than 6, so the small purple one is the greater volume. So this is my final slide, and I just want to thank you for joining me on my journey and exploring the Math Desmos activities. And through Math 303B, I've learned so much, including statistics, geometry, and just everything in general. Thank you. Have a great night.